Hi, thanks for stopping in. There's something about droids from Star Wars that I like. The way that they are, the way that they exist and seem like little people. R2 doesn't speak English. So what we know of him, we know because of how characters respond to him. We don't speak R2. But I want to. I usually have one or two big projects a year, and I want this to be one of them. This is going to evolve into a much bigger droid project at large, but right now we're just going to focus on conversation. I'm going to put all the information for the versions of things that I'm using, but really briefly, I'm using VS Code version 1.96.2. I'm using Python version 1.13.1. I'm using LM Studio to run the AI, the chatbot. That's version 0.3.6. And I'm using ChatGPT because as much as I do know, I don't know a lot, and surprisingly, it's very useful to be able to go, hi, I want something to do this, I don't know how to do it, can you show me and can you explain how it works? And it's very good at that, so super useful. I don't know how ChatGPT works, versions or models. It's January in 2025. That's the version I'm using. The basic workflow I have looks like this. You have a microphone that allows input so you can speak to the robot. That then gets sent to LM Studio, which is running some kind of chatbot on it, which is able to deliver a response. That response gets analyzed for a certain sentiment. That sentiment is either going to be happy or sad or neutral or what have you. And based on the length of the response and the sentiment analyzed, it determines what types of beeps to play and how many beeps. So if I say, hello, how are you? The chatbot responds, I'm doing well. It gets analyzed as, this is a happy sentence. And it was fairly short. So I'm going to play 5 happy sounding beeps. So let's break it down step by step, starting with the chatbot. Obviously, you need something that you can talk to and that can deliver a response. I'm using LM Studio because it allows you to import different models that people have created, and I'm running a specific model called Mistral, specifically a dolphin version of it. I can open up a local server on LM Studio and pull an API into the code that allows for the program to reach out really quickly and get a response back. There's obviously going to be latency, but at least for this, it's about optimization. It's not about relying on an internet connection. So that runs just fine. You're able to communicate with it, but the issue is that currently the code is written so that you send a prompt when the code runs and it responds to that prompt. So in order to actually communicate with it, you have to send the prompt, run the code, get the response, terminate the program, rewrite the prompt, run the code, get a response, which obviously isn't very intuitive because you have to continuously be rerunning the code. Not great. But adding running input, which basically is just a type set so that I'm able to now type a response and send it in like a live loop. Easy enough, not hard to do. I think it was like 4 lines of code if you include the break. And that works great. So you can type to it and it can type back all in VS Code. So we've removed ourselves from LM Studio as far as being able to access the bot, which is pretty great. So now that we can type to it, I want to be able to speak to it. I want to be able to interface a microphone with it. And I found a video on YouTube from All About AI, which I'll link below, that had an outline for how they created a low latency chatbot. They used Whisper as the interface for their microphone, and I wanted to use that as kind of a template. So I tried to use Whisper, but I had problems with it. There are some dependencies which I guess it didn't like, and for whatever reason, VS Code just would not import Whisper, and so I couldn't actively use it. It could have been a version error with Python, but I wanted to stay on the Python version I had. Whatever. I decided to go a different route and use Vosk. I've used Vosk in the past for wake word programs for other robots, so I'm fairly familiar with how it works, and it's useful, and it's reliable in its dictation. So it's always going to make mistakes, but generally speaking to it, it's pretty accurate in how it dictates what you say. Hello? Awesome, thank you. Exit. So writing in Vosk to the code, I'm now able to use the microphone to speak, which then gets transcribed, which gets sent to LM Studio, which then returns a response. Of course, that response is in English, which we're trying to avoid here. So the next step would be to get something to analyze that sentence, that response, and assign it a sentiment value. And for that, we're going to use, unironically, Vader. Vader is a sentiment analysis program. It basically reads a sentence and based on keywords it finds, assigns a numerical value to it, and then based on that numerical value, determines whether or not a sentence is happy, neutral, or sad. Implementing Vader was easy enough. It's limited to only happy, neutral, and sad emotions, so I want to be able to expand upon that later, which I can do, but for now it works, and it's able to read a response and tell me if a sentence was happy or sad or neutral. I just want to add that at this point I started messing around with virtual environments, and I had to completely reinstall everything because at one point I had like 6 different versions of Python on my computer, and the LM Studio and VS Code had no idea what to do, so nothing would run and everything would error, so sometimes it's bad. But now we have Vader installed, so we're able to get a reliable sentiment analysis from the response from LM Studio, which means all we really have to do now is take that sentiment analysis and determine what types of beeps and how many beeps to play based on that. For the life of me, I could not find a library of clean R2-D2 beep noises anywhere. Here's why. I think a lot of people that are building robots, that they're building droids from Star Wars, are okay with it sounding like R2 or BB-8. Like, they're cool with having those sound bites from the movies and games just play. So all the sounds that you know R2 makes, they just take the whole chunk and hit a button and play that. I don't want it to just play sound bites. I want it to play like beeps in its own random string as if it made it up on the spot. But a library, impossible to find. So I had to build one. My basic approach for this, which could probably have been done better now that I'm thinking about it, was to go online and find soundboards that people took from the games. The games would have sound files that were clean, right? Recorded and used for the game, that had no background sound, no music playing, no ambient sounds from the movies, but would reliably have R2 and R4 and whatever noises. So I found a couple of soundboards that I was able to open up Audacity, record my desktop audio, and just kind of click through the buttons they had and record full R2-D2 sounds, and then began the process of taking that WAV file, which was, you know, the full beep, 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 and separating it into individual beeps and boops. And this took probably about 2 hours. I have actual footage because I recorded it, and it stunk. It was just me going through, clipping where I could find individual cuts, keeping some that were longer, and I ended up with over like 250 individual WAV files for beep sounds. I say over because I tried to label them like happy beep 1 or sad beep 2, but then at like the 15th one I just went beep 1, beep 2, beep 3, beep 4 because it took so long. It was, oh my gosh. But I have a library of beep sounds. So in the main folder I have a couple of subfolders that are called happy, sad, and neutral. I've basically gone through all 250 WAV files and played it and gone, yep, that sounds happy, and thrown that into the happy folder. I've organized them all, so they're all put together. As far as coding goes, this was the easiest one because Python has a random import where you're able to just tell it to look at random numbers, basically. So I programmed it so that based on the sentiment analysis that came out, if it returned a happy response, it would go, okay, go into the happy folder and play 3 to 7 beeps of happy beeps, and it would string that together and it would play. Thank you. Exit. And that was pretty much it. I was happy with how that looked, but somebody suggested to me that to make it a little more variable, I would try and base the length of the beep responses with the length of the LM Studio response. So at this point, it gives a response that says happy, and it looks at 2 things. It looks at the sentiment analysis, and it looks at the length of the response. Ultimately, we end up with... Hello? Fantastic. Thank you. Exit. There is still a lot that can be improved on that. I'm not by any means saying that it's done, but I am by every means saying this is a fantastic proof of concept. I wanted to get this done, and I wanted to actually see it through, and it took a couple of days, and I've been stuck in the office, but it works. It's great, and it's very encouraging. This is mostly just a log. I have a notebook that I've started writing stuff down because I'm losing track of what I'm doing, but if you have questions or you want to talk about the bot or have suggestions or things, let me know. I'm open to pretty much anything, and I'm happy to answer more questions or go into detail for certain things. I want to make steady progress on this. I imagine it will be a long-term project, but I want to be able to keep updating this log so that I'm able to remember where I was and what things have happened and where I was able to make mistakes and whatnot, and also get feedback from people that know more than me. The next proof of concept that I want to handle is something physical. So I have a couple of servos and an Arduino coming in that I want to be able to do something based on something. So, you know, I'll see you next time.